first order of business today is for you to help me figure out why all of these pictures, if you don't already know, have to do with sexual selection. The last class, when we weren't here, I asked you to send me pictures of sexually selected traits, and this is a small sampling. Mostly, I think half of you or so chose peacock pictures and sent them to me, which is fine. So that's representative of most of the pictures I got. So why do we study sexual selection in evolution? What's interesting about it? What's surprising about it? Okay, so presumably these traits improve fitness. So that's what I'd like to start out discussing. How do these traits improve fitness? So let's start with the dewlap. Right. Which sex is this individual in the bottom left?
Male.
Okay, so male. Why does this trait improve fitness?
Attracts females, probably.
So it could be a trait. Does anybody know? I actually don't know about dewlaps. I know what they are, but I don't know what they're for. So they're attractive to females?
Or defensive of some defense mechanism.
Right. So we should look up what the dewlap is. Presumably it improves fitness. Yeah, it could be a defense mechanism. Could regulate body temperature. That wouldn't cause it to be sexually selected, though. Then you'd expect both males and females would want to have those traits. What about in the bottom right here?
They use them to defend themselves.
Okay, so antlers used for defense. How does that improve fitness?
They live longer.
They don't get killed by other males?
They're probably competing with one another to see who can mate the female.
Okay, so it's probably both, but certainly defense and then competition for mates. It sounds very much like the dewlap on the lizard. It's something that's attractive to the opposite sex. What sex are these individuals? They're males. So we got males, males. What about the peacock? Also, otherwise it would be a peahen. Right? So male. What's so great about having a huge tail that drags you down and is energetic to produce and is presumably flashy, attracts predators? How does this sort of a trait, how is it maintained in nature? Something that's that costly and that flashy and attractive to predators. It's sexual selection. Females like it. So what does that tell us about overall costs versus benefits? What's the balance on the peacock tail? Say that again? Or, well, if it was 50-50, if it was as advantageous as it was detrimental, would all peacocks have that flashy tail? Should be overall benefit. It's more beneficial overall to be able to attract females than it is a detriment to the survival. Yeah, maybe when you're an old male after you've reproduced and you don't have enough energy to drag that thing around and the predator kills you. But so what? You already had kids. And then what about all these primate traits in the upper left? All males, by the way. What about the coloration on the mandrill? All colors and patterns that females presumably like. It's attractive. Allows these primates, with perhaps the exception of the human, to attract mates. Although I happen to know, this is amazing. I was really surprised to see this picture. One of you sent it. I don't remember who it was, but this is actually a kid I grew up with.
No, really?
He went to my high school, he went to my church, and so he's married. So whether, I don't know, if they don't have kids, I don't think. I'll have to ask him. So I don't know if his beard was beneficial to his fitness, but he did attract a mate. He participates in beard and mustache competitions all over the place. And so he's got a huge beard and he styles it into different things. And in that one, he had wrapped Pabst Blue Ribbon cans up in his beard. He won some prizes. I don't know. But anyway, so that's Chad.
When I seen it, I thought I should post it because it's just pretty funny.
Well, it's excellent. So thank you for spotting it. And you can actually, yeah, his picture's actually all over. If you search for funny beards or something like that, you'll probably see a lot of his styles at different competitions. Why didn't we see any female pictures? Why are those all males?
Because we get to choose, they have to fight for it.
That's right, ladies. The males fight over the females. One of the patterns that I want to talk about today and through this whole week we're talking about sexual selection in class. Why is it sex specific? Why is it usually males and not usually females that have these traits? So even Darwin himself noted that it was usually males that had traits that differed from females, and that they were often the flashier or more elaborate. And so definition of sexual selection: any traits that are useful for competing for or attracting a mate undergo sexual selection. That is, they're selected for, those traits are maintained, selected for only in one sex, not both. So anytime you see sexual dimorphism, where the two sexes look different, usually there's some sexual selection going on there. Here's an extreme example of sexual selection. Isn't that male sexy? So these insects from the genus Teleopsis, tele like telescope, long, and opsis, eye, these are stalk-eyed flies. And they live in, these ones were photographed in Malaysia, and these were studied in Malaysia, this paper from Jerry Wilkinson in 1994. Basically, these males and females live on these grasses and roots that sort of hang down over rivers in Malaysia. So this is taken right above a body of water. So they boat down the edge of the river, and these males have obviously these really long eye stalks, and there'll be one male per piece of grass or root, and then a collection of females. And they're presumably choosing whether or not they like to mate with this male. So there'll always be one male and multiple females. So the males pick out their favorite piece of grass or root, and then females come and try to mate with the male. Presumably the females prefer males with longer eye stalks. Who knows why? We don't know anything yet, I don't think, about the basis of that, why the females think that long eye stalks are sexy. But who really understands females anyway? I'm sorry. Just kidding. So what might it signal to the females about the length of a male's eye stalk? Why is that a sexual signal? Why is it a beneficial trait?
Maybe it indicates a level of survivorship or advantages because maybe it has a wider range of view.
So it could be, presumably, these long eye stalks could be beneficial to the males, maybe improve their view, allow them to detect predators quicker. What other thoughts? So I'm not discounting that. It's one idea, and there is no true idea. There's no right idea. All we can do is come up with hypotheses.
To go from one place to another without falling to the other.
Transportation. Say that again?
Maybe from one to next without falling.
Yeah, so it could, or balance, center of gravity. Think person walking across the Grand Canyon with a big long pole to lower their center of gravity so they don't fall down into the Grand Canyon. Sure.
Could be that the females recognize that longer eye stalks means better fitness, and so if a male has longer eye stalks, that means that their lineage has survived a lot longer than other ones.
So it's possible that it has something to do with the quality of the male. That if they have longer eye stalks, that means they're somehow better. So long eye stalks might mean that male has high enough physical fitness, not evolutionary fitness, but the ability to collect food, have energy to actually grow longer eye stalks. So maybe the males with the longest eye stalks are the ones that are the most healthy, not the most fit, most offspring, but the healthiest, maybe. So it could be, is that a similar story to peacocks? Longer feathers or brighter feathers. So it takes a lot of energy to make the pigments that make the peacock tail so flashy. So yeah, that's a signal to females that, oh, this male's got more resources. And so Jerry Wilkinson and his team went to Malaysia, they boated down the river, and every time they saw a collection of Teleopsis, they counted how many females on the y-axis. So here's a male at the top, how many females are hanging onto his grass. And then they took the male and they measured how long his eye stalks were relative to how long the body is. Because you have to, presumably eye stalk length would scale with body size. You have a longer body, you have longer eye stalks. So they took the ratio of that, eye span to body length, over here. So what's the correlation? The bigger the eye stalks, the more ladies you have on your twig, I guess. So this was evidence that sexual selection is occurring, that females are choosing to hang out with males that have longer eye stalks. What's going to happen to this trait over time? So it's going to get selected for. So if there are mutant males that have even longer eye stalks,
They're gonna get selected for as
th-
well.
then do you have even, we're talking about extrapolation here, are they going to get even more females to mate with? And they pass the genes on that cause longer eye stalks to more offspring. What's the ultimate outcome?
Extremely long eye stalks.
Yeah, extremely long eye stalks where they can no longer hold them up and they bend over and they drag in the water, or who knows. This is what's called a runaway sexual selection. This is an example of runaway selection, where you can imagine that if there's no break to this process, if females keep preferring males with longer eye stalks and males keep growing longer eye stalks, this is going to continue ridiculously forever, until there's some sort of limitation, like males can't actually physically grow eye stalks that long.
So are their eyes really at the end of the eye stalk?
Yes. Males. So why is it that female ornaments, somebody mentioned already that females get to choose who they're going to mate with. This is true in most species, not all species. Why males? Why do females get to be the choosy ones and the males have to compete for the females? We have about the same number of females as males on the planet in humans, so it's not like there's a limited number of people to mate with.
The only number of eggs.
For ourselves, some of them have to be
So you want, okay, right. So females want the good genes for their offspring, but certainly the males, presumably. So can't we select for females that have sexually beneficial traits? Right, so it's costly, exactly. So I'm hearing a few of you say things that are related to the theory, evolutionary theory, of why females get to be the choosy sex. A, they produce the more limited gametes. So oocytes, right, there are fewer of them, they're bigger, males produce masses and masses of sperm all the time, females have a finite number of eggs. So presumably, evolutionary theory says that the females would want to be the choosier sex. They want to ensure that they're picking the right mate to ensure that their rare gametes pass their genome on to the next generation. So that's one theory. So whoever produces the bigger gamete and the rarer gamete will be the choosy sex. It's not always true. Mostly it's true, not always. Anybody think of an example where the male is actually the choosy sex?
Well, I did remember there was a species of insect or something where it produced like one large sperm package or something that the females had to pretty much impress the male for.
So there are, right, so impressing females with your sperm packet. There is something that I wasn't planning on talking about, although we certainly can if you want to digress into this in the next day or two, male nuptial gifts. So sometimes males give presents, sometimes sperm, or related to sperm, to females to curry their favor. So bowerbirds is not what I'm talking about. Nobody said that, I'm just bringing it up. So there's this idea, bowerbirds, the males collect lots of blue objects and decorate their nests with blue things to try to attract the females. A nuptial gift in insects is when the male actually packages a lot of nutrients into a spermatophore, which is an object that travels with the sperm, so that if the female allows the male to deposit his sperm, then the female gets an energetic, basically, gift, high nutrient spermatophore. So this is something that some species do. And in that case, sure, the male then might want to be the choosy one because he's spent energy to produce and to secrete energy into the spermatophore. He's going to be choosy about who he gives it to. Like big diamond rings or something like that. There's seahorses. One of the reasons that seahorses are really cool to study for evolutionary biologists is because they're one of the species where there's been sex role reversal. Where the males are the ones that carry the young in their brood pouch. And so males maybe then are the choosier sex. So males are the ones that pick which female he wants to mate. So absolutely, it has to do with investment. Not necessarily just in the oocyte, but then also, as somebody up here suggested, also brood care. Who's taking care of the offspring? So if you know that in your species, it's the male that takes care of the offspring, maybe the male then will be the choosier sex. There are two types of sexual selection we're going to talk about. So we've got precopulatory sexual selection. This is one of the goals for today, is to try to define what we're talking about by when we can categorize sexual selection into traits that occur before copulation and after copulation. So then, selection always occurs between two individuals. So what are all the different combinations of individuals we can have? We can have male-male, what else? Male-female, and female-female. We have three different combinations of the sexes that can experience either precopulatory or post-copulatory selection. What have we been talking about already? What sort of traits have we been talking about? Let's fill in this table a little bit. So eye stalk length. Is that?
3.
So that's before copulation. So this is something that the males use to attract mates. So this is female-male precopulatory sexual selection. So that's to attract mates. That's between sex, intersexual. Sexual selection. What else? We saw antlers, first slide. So that's male-male. Does that occur before or after? We're not talking about the males copulating with each other, by the way. Is that before copulation or after copulation? That sexual is before, right? You're competing, again, you're competing for mates. So that's intrasexual within the same sex. Intrasexual selection. Male-male, male-female. Female-female? We haven't really talked about it yet, because it's so rare. Because in most species, as we've discussed, it is the females that are the choosy sex. So there's not often a lot of female-female fighting for mates before copulation. There are in some species, but the overall pattern is it's rare. So at this point, let's see, post-copulatory. We're not going to get to this until one of the later classes. Can anybody think of examples of selection on traits that occur after copulation? Go ahead.
Well, I was just gonna
Yeah,
ask,
that's fine.
is it possible for a female to be like inseminated twice and then whatever sperm makes it to the egg first? I feel like I've heard of that before, but I don't know.
Yes. So when you have multiple males inseminating a female, then there are two things that can happen. I don't want to tell you, though. I want you to tell me.
Well, either only one will make it or both can make it and make, because like, you know how dogs can have different fathers or whatever, the puppies or whatever?
Yeah.
So,
Yeah. Okay. Otto?
Just gonna say sperm competition.
Okay, so there's sperm competition, and then there's multiple paternity. So either a female gets inseminated by multiple mates, and all of those sperm fertilize eggs, oocytes, and you get a litter with multiple fathers. That occurs. But that's not necessarily selected for, but you can have, after copulation, between in the same sex, male, have sperm competition. It's like the Olympics for sperm. That's something we'll talk about when we get to next class, talk about post-copulatory more. But the idea that sperm gets selected for to be what?
Fertilization.
For fertilization ability. So how do you win the race to the oocyte?
You have to be fast.
You gotta be fast. So sperm evolved to be faster, literally, to try to outcompete the sperm from other males to gain access to the oocyte, and then those are the traits that get passed on to the next generation. What about fertilization has to do with intersexual male-female post-copulatory selection? This happens in that multiple paternity case. Female gets inseminated by multiple males.
Isn't it in the ends that, like, the female could eject some of the males they don't want to mate with?
Right. So there is actually, in some species, a way for females to actually choose which male fertilizes the oocytes. So you can actually have females selecting against male sperm of certain suitors. And then, as far as I know, there's no female-female post-copulatory sexual selection. So all of this is driven by reproduction. It's gametes, it's weapons, what we call traits that are used in sexual battles, intrasexual, within the sexes. So males have weapons. Those are the things that they use in competition for mates with the same sex, male-male. And then we've got the intersexual selected traits, male-female. We don't call those weapons, we call those ornaments. Think Chad with the beer cans in his beer. We've got weapons and ornaments, two types of pre-copulatory traits. The next class will look a lot more at post-copulatory traits. Any questions?
Can you briefly go over the sperm place?
I'll do that next class, actually, but I will. So yeah, post-copulatory sexual selection I'm leaving for next class because right now, I know everybody, almost everybody, is finished writing their term paper. If there was any issue with submission, I've already contacted you. So if you haven't gotten an email or a Google Classroom post, everything's cool. I'm not saying I graded it yet, but it looks like something I can grade. I can access it, I can read it. So continuing on in the pursuit of the end of the semester, for many of you the end of the last semester, congratulations. I want to start you thinking about the final exam now. So the term paper was worth at letter grade, 20% of the points in the class, so does the final. So if you'll go to the last slide in the PowerPoint or in the PDF, it gives you your URL. I've put a mock exam. I just want to give this opportunity. This is for participation points only today. Several questions. I wanted to give you time to do this. It'll stay open a little bit past 9. But go to the link, click the link. It's a web-based survey form, multiple choice, to try to start having you recall some of the material we've covered across the term.
On Blackboard or is it on?
Blackboard. So in Blackboard, in the course documents folder, the URLs folder, and then it's called mock exam. There's a link to a survey on the web. So I just wanted to give you this opportunity. You don't have to do it. It's for participation points, just a couple. But hopefully it'll help you recall some of the material we've covered across the term, because in a week, we're done. And next Wednesday will be a review session. So we have content today, Wednesday, Friday, next Monday, and then bring questions next Wednesday to class, and we'll talk about anything from the semester. Okay. So work on this now if you like. You've got in-class time to work on it. And otherwise, I'll see you next class.